Hello fellow modders, welcome back to Unique Amps. I hope you're safe and healthy wherever you are in the world. Thanks again for joining me. It's been a while since I made a video working on our custom 12 gauge. Sorry about that. Been really busy with other stuff. Today what I'm going to do is replace that third op amp, the third IC and the preamp. And also this is going to be a little bit of a soldering tutorial, so I hope you enjoy it. I've got this new adapter for my camera so I can take video using a microscope, and so I'm curious to see how this turns out. So let's check it out. First step, as always when working on this kind of stuff, is don your safety glasses. Hey Don? Yeah, bro? Your safety glasses? Oh yeah. Thanks, bro. Alright, in order to solder, you of course need a soldering iron. And the one I'm using, my latest purchase in this respect, is from Marlin P. Jones and Associates. There you can see it. I'll put a link in the description, and there's a screenshot in the lower right hand side of the screen. So I mean, that's the first thing that you need. This one's a little bit more fancy. It's got a digital temperature control on it and has the built-in cleaning sponge. I have to look and see how much it was. Like I said, I'll put a link and you can check it out for yourself. But basically you can get started with, say, like a $10 or $15 15 or 20 watt soldering pencil. You know, you don't have to break the bank to get equipped to solder, but that's, you know, number one thing that you're going to need. And then of course you're also going to need the solder. So this stuff I'm using, and sorry I don't remember the brand. It's probably, I got it from one of the online distributors. Again, like it's either Marlin P. Jones or Electronics Goldmine or Jameco or somebody like that. I don't remember, but definitely get you know, electronic solder. There's a big difference between this and the stuff that you get for sweating copper. So you definitely want flux core. This stuff looks like it's 60/40 tin lead and 0.8. Was it 0.8 millimeter, I guess, diameter. Right? If you do get a soldering iron with a temperature controller, you're going to want to set it up so that it's hot enough to melt solder and heat the joint within a few seconds, but you don't want it to be too hot either and vaporize the flux that's in the solder. So you want it to, you know, a happy medium. Typically it's going to be like 50-ish degrees above the melting temperature of the solder, which is typically around like 270 C, give or take, 250 to 270. So you want it like, I got this one set to 340 C. This one, so you can change between C and F. So Fahrenheit, I'm at about 650. I've used a lot of Weller's the brand. We used to use Weller's a lot, or we still use Weller's a lot where I work, and the tips are rated for 700, I think. You can get different tips at different ratings, but the most popular tip that we usually use is around 700 degrees Fahrenheit. So again, we're sitting there around that area. So that's the the first thing. You're also going to need a few other tools. In this case, I'm going to be desoldering this IC here. And really what I'm going to do, I'm not going to use it again, so I'm just going to cut it out. Cut it out. I'm going to clip the leads using a side cutter, and then pull them out with a tweezer, heat them up with a soldering iron, pull them out, and then I'm going to need to go back and clean up the solder joints with the, this brand is Chemtronics, and really it's a soldering braid, so it's a braid of copper wires that's impregnated with a lot of flux. Gives it a lot of wicking action to suck up that solder and clean the joints off. Alright, you see my setup here. I've got microscope on this 80/20 base, and I've got my SLR hooked up to the adapter, recording video on that IC. What I'll do, I'll set this camera up so you can get kind of a side view of what's going on here, and then I'll switch back and forth between this camera and the other one. Alright, try this here. Let's see. This one. Yep, okay, let's try it. So I'll probably speed some of this up because it's a little bit boring, but I'm gonna cut these. Can I even get in here? The microscope. Jeez. This isn't easy, friends. There we go. Alright, see if I can capture that. Wow. There's my light, of course. Try to get this in focus. Okay, there's half of it. And let's turn it around. Focus again. It's not the easiest thing in the world to do. Damn. You know what I'm gonna do? I'm gonna just desolder this without the cameras, and then show you how to solder a new chip in. Actually, you know what? Screw that. I'm gonna do my best to get this on video. Damn it. So I think those are the IC connections. Sorry about the light. See if I can get this in a little closer. Yeah, okay. Not terrible. Let's get rid of that solder. Say can you see what it's doing? Alright, so that's the side that I cut. I want to get only the holes that I'm modifying, not the adjacent ones. Try to get the focus better for you. Yep. Okay, better. A little bit. Do the other side. Alright, now this side I didn't cut at all. Still connected to the IC. Braid does a pretty good job. So I'm going to clean the soldering iron again. Get rid of what I've used so far. Right. Next. So you see how it just sucks right up in there. Okay, not terrible. There we go. It's loose. See that? Okay, pull it off. Oops. See what I'm doing? Alright, that's the spot where the IC was. The PC board. Let's get rid of this one. So you can see what I'm doing here. Right. Yep. So there you go. IC deleted. Oh. Holes are clear. Don't have any solder bridges. And what I like to do is I'll go back and make sure these holes are clean. They look pretty clean as is. But just to give you an idea of what it's capable of here, the capabilities. And the other side. Clean the tip again. Okay, good. Alright. Bring your tip. Not gonna need the solder braid anymore. So I can put that aside. Get rid of my garbage. Alright, and just like, here's the other legs cut off of there. So just like where are we at? Just like these other spots, IC spots, I'm gonna stick a socket in here so we can change out the ICs when we want to. Okay, so what I do is, you see the silk screen, if I can find it, there it is. Silk screen shows the outline of the IC body, there's always a notch in one end. And then you can see right there, there's a number 1 next to one hole, number 8 next to another hole. So that's pin 1, 2, 3, 4, 5, 6, 7, 8. So when we're installing our socket, I want to match up the little divot, notch, whatever you want to call it. Right? So that our pin out, because the connections have to be exact. Alright, so I'm going to do on this one, what can I do here? So this is going to be a little tricky in order to tack this in here, but I've been doing this for a long time. So what I'm doing is I'm holding the socket on with my pinky finger, and that gives me, where am I here? That gives me the use then of my thumb and forefinger. And then with my other hand, I'm going to grab the soldering iron, clean the tip, and then quickly tack these just to hold the socket on there. And it's not a great solder joint, but I'll go back and clean it up if it's necessary. And then the other side, just make sure that it's on there. Come on. Okay. All right. Now there's probably 1,000 soldering tutorials on YouTube, but here's my take at it. So for PC boards, it's really straightforward, and that's why, part of the reason why PC boards have become standard for all consumer electronics. They're really easy to solder. There's different soldering methods. They can be automated, but for soldering manually, for the hobbyist, you do have to go through a few steps to be successful. So for a PC board, it's pretty straightforward. So what you really need to do is, when you're soldering, what you want to do is apply the heat to the joint, and then apply the solder to the other side of the joint. So in this case, what I'm going to do is apply the heat to one side of both the pin. So I'm going to place the tip against the pin and the pad on the PC board, the copper clad, and then feed a little bit of solder on the other side. So I really want you to see how the solder flows here. See how much of so this is the first time I'm using this adapter on my camera with the microscope, so hopefully it turns out good. So again, cleaning the tip, it's very important. Sometimes you add a little bit of fresh solder. I'm not going to in this case. So I'm going to just lay the soldering tip against both the pad and the pin, if you can see that. And then feed the solder in, and you can see how the yellow liquid, that's the flux. And that's a little bit too much solder, but it's okay. I tend to use a little bit too much, I guess. But what you want is you want that whole area of the pin and the solder pad coated with solder. You don't want any voids. You want the surface to look smooth and shiny. If it's not smooth and shiny, if it looks dull, and if it has some cracks, It could be due to a low temperature, or if the pin or the joint that is soldering moves during the when the solder is cooling. You notice that there's still a little bit of yellow flux left over. We'll clean that off with alcohol later, but you actually want that, because what that does, it cleans off any oxides and produces a better solder joint. The tin lead, it's able to stick to the solder pad and the pin better with the flux. If the tip is too hot, it's likely to vaporize that flux, and you won't end up with a little bit of flux residue afterwards, and you could end up with a dull solder joint. And dull solder joint is a weak solder joint, so you want it to be smooth and shiny. Let's go on to the next one. Clean the tip again. Again, put a little bit of solder on the. There you go. And you see how it cools? I'll do the next one in slow motion, so you can see how it cools. So when the solder joint is still hot, the the solder looks shinier, and then if you watch it, you'll notice that it kind of goes a little bit more dull, and that's what happens when it's cooling, when it solidifies. There, you saw it again. So that one's pretty good. That one I didn't put too much solder on. Yeah, that's a pretty good joint right there. Actually, it could still be a little bit too much, but. And then the corner that I tacked earlier looks fine. Should be adequate, so I'm going to leave it. The other thing that we're going to look for is making sure that there's no solder bridging between the connections. So you see right in this, the space between the connections, there shouldn't be any solder bridging those areas. So you see it's clear. And I'll clean this later so you can see it better. Do the other ones. Go a little more quickly. Okay, you can see there's a solder ball there. No big deal. You want to probably try to get rid of that afterwards, but since it's touching the solder pad, what's going to happen is it's going to melt when I solder this joint here. Watch. And there it becomes part of the solder joint. Alright, let's do the last two. That's a good one. And last one. Whoops. You see how because the solder tip is big, I was heating both these two joints at the same time, which is okay as long as there's enough flux left and that you don't cause a bridge here. So it looks like I did not create a bridge. It looks pretty good. All good. So that is soldering PC boards. I think I'll show you how I solder wires together, just for your information, and then also maybe soldering a wire onto a terminal. Alright, now I'm going to show you soldering two wires together. So this example, this is a transformer, and it has wires coming out, and in this case It already has tinned leads. So you see it's copper wire with tinned leads. And what I want to do is just solder another wire onto it. I want to solder this onto it. And if you look at, if you do some research on soldering wires together, or making joints with wires, electrical joints, it'll show. I think I just inhaled a bug. It'll show you in order to create a strong solder joint, you need to twist the wires together or overlap them and twist them together. And for most electronics, that's unnecessary. So for wires that are going over a long run, especially like externally, or if it's military grade, wires that are going to be subjected to a lot of mechanical shock and vibration, then yeah, you probably do want to twist them together and then solder. But for most solder joints, it's unnecessary. The solder itself is going to be strong enough. And I've learned this, I learned this 20 years ago when I started in my career essentially building automatic test equipment. What happened here? Essentially building automatic test equipment. You don't need to twist the wires together for every joint. Really all you need to do is tin properly the copper, and then when you solder them together, the joint itself is going to be strong enough, and then you cover it up essentially with some shrink tube, and it's good enough. I've built dozens of pieces of equipment that have been deployed all over the world, and almost never do the solder joints break, or they're never a problem. If the equipment has an issue, it's almost always something other than the solder joints, especially the things that are built by hand. So when you're building something by hand, you can ensure that the solder joint is definitely more than adequate. So I'm just going to strip this other wire, and I just want a piece exposed that's about the same length as the original, or as the piece that I'm going to solder to. Damn near perfect. Then I'm going to twist. So I want to twist the strands so that they don't fray. And let's see if I can put this under the microscope so I can make a demonstration here and hold it in place. Come on. Alright. Don't breathe on it. Get in focus. Get in the center. Son of a bitch. Come on. There we go. Okay, so you see this wire compared to the transformer wire. This stuff is already tinned. So it's tin coated copper, which makes it a lot easier to solder. But you still want to tin this, and what that means is you essentially soak it in solder. So again, I'm going to get a little solder on the tip there, and then heat the wire, and then all you do is just feed a little solder there, and then you see how you get the solder soaks up into the wire. You get a nice shiny. All the strands are connected together. Again, you don't want to overheat. You see a little bit of the insulation here is melted. That's normal, but you don't want to melt the crap out of it. And right there is essentially what you want. Alright, so then connecting to the other side, and then also, you know, this already has solder on it. However, I want to freshen that up a bit. So what I'm going to do is the same thing. Same thing as I did with the unsoldered wire. I think that bug is stuck in my throat. I'm serious, I think I inhaled a little fly while I was talking there. Crazy. Anyway, it's the same thing. A little bit of solder on the tip, and if you do a few of these, you get used to, you know, what is all required. You can see the flux is soaking in there first, and you see the fresh solder wicking up, and as the flux is boiling away, again, you're not vaporizing it, it's going to boil a bit. You want a little bit of the flux left over. And then as long as I have this in, I don't know if I can do this. Jeez. Not easy doing this on camera. So now that both sides are tinned, what I can do is put a little bit of solder on the tip of the soldering iron, and I want to do this quickly so I don't boil off all of the flux. But essentially all you do is just hold the two wires next to each other, overlapping like this. See if I can do this under the microscope. And then you just hold the soldering iron to both and allow the solder to flow. Give it a couple seconds. And that is terrible. Not easy to do under the microscope. Alright, let's try this. Okay, I don't want those wires to separate. Normally what I do, I'll go this way. So I'm right-handed, so I normally, and this has gotten kind of screwed up. So here's what I'm going to do. I don't like this. I'm going to, let's see if I'm still seeing overview here. Yeah. What I'm going to do is cut the shorter, tin it again, do it right. Oops. Yeah, and that's what you don't want. You don't want the single strands to fray out like that. Come on. I am not having the best time here. Okay. Okay. You can see we got bare copper there. Tin it. Good and tinned. All right. So we're going to put this, still hot, and you actually don't want to handle it until it's relatively cool, but okay. Got the other wire ready. What I'm going to do is put a little bit of solder on this tip and then hold the wires together that I want to make the joint. There you go. And that actually is strong enough. So you see how the solder flows between the two? And there is no way in hell you're gonna be pulling that apart unless you, yeah, there's no way. I mean, I'm pulling at it really hard right now. You're not gonna pull that apart. And unless your wire is part of some sort of structure, or that it has to hold itself up over miles, there's no reason to have to twist the wires together. This is good enough. So then what you want to do is get a piece of heat shrink and put it over this, and then shrink it up so that there's no exposed metal. Alright, so that's two wires together. Let's do wire onto a terminal. Alright, wire on a terminal. Now this is a choke similar to a transformer, but just one winding. And I've already got the top of the terminal there. So this already has some old solder on it. So first thing, I'm going to refresh the solder, give it some new solder. Much better. Alright, and then I'm going to tin the wire that I'm going to use. And there's a couple things you can do here. You can either do, you can wrap around, you know, which, fine, you want to wrap around, great. Makes a good mechanical joint. Or you can just do what I'm going to do. So first I'm going to tin this wire. And I like to leave a little blob of solder on the end. So you can see that there. There's a little solder there. And all I'm going to do is just melt the two together. And you can either do it, you know, this way, and then just stick a piece of heat shrink over the top, which is fine, or you could do it this way. And again, just some heat shrink afterwards. Either way, the choice is yours, depending on am I recording or not? Jeez. Either way, the choice is yours. I don't think I was recording on my microscope there. So let's do that again. So I'm going to add some fresh solder onto this joint. Right? And I've got this tinned, and I think the other camera got it. Alright, so I'm just going to solder this. Let it cool. There you go. And again, it doesn't matter that this isn't wrapped around the terminal. You can see that terminal moving as I'm pulling this. That solder is not going to break. So to me, there's really no reason to wrap your wires around terminals, to wrap the wires together, you know, unless you're expecting that wire to, you know, be structural somehow. And you know, the solder joint's just not gonna just break on its own. So there you go. That's this helps you if you're new to soldering. This is how I do it, and I've been successful for over 20 years. So you know, get the tools that you need and start practicing if you're interested in soldering and electronics. Okay guys, now it's time to install the new operational amplifiers. I only have two of the Analog devices, what number is this? It's AD823, so it's a low noise, high slew rate operational amplifier. I'll put the link to the data sheet in the description. I only have 2 of those at the moment. Those are decent for audio. The other dual operational amplifier that I have at the moment is the LF412, which doesn't have as good ratings, but it's still decent compared to the originals. Again, I'll share a link to the data sheet in the description. So the first thing to be aware of when working with integrated circuits is that especially in dry climates, this time of year in southern Wisconsin, it's not very dry yet. It's still relatively humid, so static electricity isn't typically an issue, but definitely once it gets to be November, December, January, winter, and it's drier inside, then static electricity becomes more of an issue. So anytime that you are going to come in contact with integrated circuits, it's best practice to use a grounding technique, and there's a lot of different things that are that are commercially available to ground, to make sure that you dissipate any static electricity that you have built up in your body. It could be as simple as just touching a cold water pipe before you touch the integrated circuits, or what I'm gonna do is use this wrist strap that's made for this purpose. So these wrist straps are essentially just a piece of elastic with some metal making contact with your skin, and then usually there's like a cold wire, so that it gives you a little bit of flexibility. And most of these also have a built-in resistor that allows a dissipation, controls the current a little bit, but really, even just a simple wire is going to be effective. So what I'm going to do is just slip it on my wrist here, and then this end, the banana plug, I'm going to stick into the ground of my outlet strip and make sure that it's actually grounded. Obviously you don't want to stick it into the hot side of anything, but really all I'm doing is just plugging it into the ground, and it should be good to go. Alright, so what we're doing here is replacing ICs 1, 2, and 3 on the custom 12 gauge circuit board. We remove the original ICs and change them to sockets. One thing about these integrated circuit packages, when you pull them out when they're fresh and not used, I don't know if you can see this, the feet are spread out a little bit. So what you want to do is bend them in slightly, and usually just what I do is press them against a flat surface. So I'm just going to take my fingers like this and just push them inward slightly so that they're at more of a 90-degree angle compared to the body of the IC. So I'm going to do that with all 3. Just a little bit, doesn't take much. Just makes it a little bit easier to stick into the socket. Alright, there you go. And I've decided that I'm going to use the LF412 in IC3. Alright, so there's IC3 here, and then also remember we lined up the notch with the end of the socket matching it up with the silk screen. I think that bug is still in my throat. Matching up with the silk screen so that our pin numbers are matched up properly. So when you look at the IC, there's a little notch in the body of the IC here, and then also there's usually like a circular indentation right next to pin 1, and then also, you know, the labeling, the silk screening is oriented so that when you look at it to read it, pin 1 is going to be to your bottom left. And of course, you know, it's paramount that the pin numbers are connected properly, because if they're not, it's just, you know, and it's not going to work. Alright, so I got those started in the socket, and just push it down until it stops. So there's one. Whoops. Alright, the next one, IC2, again, that's going to be, so I've got the nicer op amps are going to be more toward the front end of the circuit. Right, again, lining up the notch. Pin 1 is where it's supposed to be. IC2 and then IC1. And no, it doesn't matter which one you connect first. Just get them all in there. And make sure, and I've seen this occasionally, make sure that the pins are properly inserted and they're not bent. I've seen cases of when these were installed of where one of the pins caught the edge of the socket and got bent upward and didn't actually get seated fully. And it worked initially because of making connection initially, and you know, worked for years, and then suddenly stopped working because enough oxide built up between the bent pin and the socket and made a poor connection, and you know, it caused the circuit to stop working. So you gotta make sure that everything is installed properly, connected properly. You know, take your time now, and if you take your time now and make sure everything is right, then you have a higher likelihood of you know, your modifications working indefinitely rather than running into problems down the road. Alright, so what I'm going to do now is these are installed. I'm going to get this board put back into the chassis, and get the chassis put back into the amp enclosure, and then see what it sounds like. Alright, hopefully you all can see this. All I'm going to do is stick the chassis back in. And no, I'm not wearing my wrist straps at the moment because I'm being careful not to touch any of the electronics. Oh, alright. This way. Okay. And I'm gonna stick the heat sink screws in first. Try not to cross thread it, although these are just sheet metal screws essentially, it's not that big a deal. But you really can only loosen and tighten these so many times before you strip out the holes. And then I'm going to pretty much just attach the nuts on the endmost potentiometers just by hand, just for now. I should probably also do that on the input. Okay, just turn all of the pots down. Yeah, I'm gonna stick the input jack. I think this is right. A little plastic grommet there, another washer. Man, that bug is totally screwing up with my throat, my voice. Alright, so we need to reconnect the audio connections. Should be just simple push like that. Cool. And then power, put them back in the same way. I think red is to the outside, yellow's in the middle, makes sense. It's a center tap transformer. Make sure that they snap in. Doesn't have to be perfect, but just they only go on one way essentially. Yep, they're on. Okay, great. Alright. Get the enclosure back in here. And I think I lost a screw. I'm gonna have to look around for it. Unfortunately, oops. But 3 screws should be enough, at least for now. It's gonna go in like this. Get it started. Okay, there's one. Two. Tight. Actually, 2 probably would be enough for now. I think I'm just gonna stick with 2. It's not going anywhere. Actually, you know what? I do have all the screws. I got them in here. Fantastic. Okay. Let's see if it works. Gotta connect the old Celestian again. White is plus. Okay, they're just push terminals. Oop. Stick them on the side there. The cats have got a lot of cat hair on this enclosure since the last time I used it. Looks like it's ready to rock, so let's get the guitar out and try it. All right. Okay. Okay. Alright, I'll be using my trusty Ibanez RG140. I already tuned it. Just tuned it. Alright, so right now I'm on the neck pickup. And we're doing just a clean channel for now. I've got low turned up like quarter, mid, 3/4, and high 3/4. Effects are off. Right. We got middle and neck. Okay. Okay, why don't we try 30 channel, of course. Alright, so let's go with, I'm back on the neck pickup. Let's turn the volume all the way up. Gain. So yeah, okay, so what I gotta do is dig up the audio that I previously recorded with the original ICs, and probably what I'm going to do is set up the same conditions. So you gotta put this thing up in the closet and go back and review the video and compare the settings, set everything up the same, set up the microphone the same, etc., etc., play the same riff and compare how they sound, see how the sound difference is. So stay tuned. Yep.
What are you doing?
Making videos.
Okay.
You want to be on it? Asawa?
Gonna be.
Okay.